Alright, so I'm not quite sure where we ran out, so we're just going to start assuming that we got a little bit, we had talked about a rolling versus grade resistance, that a rolling resistance is the tire penetrates into the soil and it deflects on its own, so it's perpetually climbing out of a hole. Grade resistance is you're going up or down a slope. And so a rolling resistance, we can look up various factors, which gives us a factor in pounds per ton of gross vehicle weight. So for example, if we're operating in loose sand, a rolling resistance can look it up and find that that's 75 pounds per ton of gross vehicle weight. If our gross vehicle weight is equal to 100,000 pounds, which is 50 tons, then our rolling resistance is equal to 75 pounds per ton multiplied by 50 tons, and that ends up being 3,750 pounds. Now, the other cool thing that goes on, of course, is we have our grade resistance. And a grade resistance, we have 20 pounds per ton percent slope. So if that same vehicle goes up a 4% slope, then its grade resistance is equal to 20 pounds per ton gross vehicle weight percent slope multiplied by 4% slope multiplied by 50 tons is equal to 4 times 20 is 80 multiplied by 50 is another 4,000 pounds. Rolling resist or grade resistance. So our total resistance is equal to the rolling resistance plus the grade resistance, which is equal to 3,750 pounds plus 4,000 pounds is equal to 7,750 pounds. That's our rolling resistance. We can also convert it the other way around. If we go back and we reconsider our problem, fix that and make it a little easier to read. If we reconsider our problem, we had a vehicle, his gross vehicle weight was 100,000 pounds, just 50 tons. And it's going to go up a 4% grade and then return downgrade. And this particular vehicle is going to come back and go at the same weight. Obviously, if it's carrying a load, it may be much lighter coming back down. But we can work this same way. Going up, our total resistance is equal to the rolling resistance plus the grade resistance, which we said was 3,750 pounds plus 4,000 pounds for a total of 7,750 pounds. If we're going down, our total resistance is different. Our rolling resistance is 3,750. Because even going down, the soil always opposes rolling. Minus 4,000 pounds, because going downhill is easier. Gravity is working for you and not against you, and that gives us a net of minus 250 pounds. Now, we had said that 1% slope is equal to 20 pounds per ton gross vehicle weight. We can use this the same way and go in the opposite direction. Going up was equal to 7,750 pounds. to multiply that by 1 over 50, right, gross vehicle weight, to convert it to our base rolling resistance. And that's 7750. $77.50 divided by 50 gives us a total resistance of 155 pounds per ton gross vehicle weight. It's equal to 155 pounds per ton divided by 20 pounds per ton per percent. And that is an equivalent grade of 7.75%. So climbing that 4% hill with the rolling resistance as we have calculated gives us a 7.75% grade. Going down, it's the same thing. Now we're at minus 250. We divide that by 50 to give us our total resistance factor, which is equal to 5, negative 5 pounds per ton. If we divide that by 20 pounds per ton per percent grade, this gives us an equivalent of minus 0.25% slope. So we can convert back and forth, and obviously you can, if you already had the 4% grade, and let's take a look at our up again. We said that was a 4% grade. Our rolling resistance, we had said, was equal to 75 pounds per ton. If I divide that by 20 pounds per ton percent, it's going to give me a resultant percent. And if I take 75 divided by 20, I will get 3.75, and my total grade is equal to 4 plus 3.75, which is equal to 7.75, which is the same as we had calculated before. So you need to be comfortable changing between these two measures, and it should be straightforward. I'll give you another small assignment to make sure that we've got this one. Thank you. Bye-bye.